Dear students, we are solving the IB Math A HL past papers, and currently we are solving the IB Math A HL November 2021 paper 3. Today we will be solving the question number 2 of this paper. We have already solved the question number 1 of this paper. You will be getting the links to all the previously solved questions of this paper. It is question number 1, and of the other papers as well, in the form of playlist in my channel. So, without any further delay, let us start answering question number 2. The maximum mark is 30. In this question, you will be exploring the strategies required to solve a system of linear differential equations. Consider the system of linear differential equations of the form dx dt equal to x minus y and dy dt equal to ax plus y, where x, y and t are positive real numbers and a is a parameter. First, consider the case where a is equal to 0. And this is subpart A, which is containing 3 further subparts. Subpart I is by solving the differential equation dy dt equal to y. Now, when a is equal to 0, this term is equal to 0. So, dy dt is equal to y. Show that y equals a times e to the power of t, where a is a constant and this contains 3 marks. Fine. So, this is ai. Dy dt equal to y, or this is equal to dt, and if we integrate both the sides, we get ln of y is equal to t, and the constant of integration, because they have given this a, I am taking the constant of integration as ln of e, because I have to get my answer in this form, so you have to take the constant accordingly. Okay? So, and doesn't matter, even if you take c, a is any constant. So, a can be a constant in form of an expression. That is also fine. I am taking the constant as ln of e. Okay. So, this is ln of y minus ln of a equal to t, or ln of y over, actually this should be the modulus. And doesn't matter actually. Y is a positive real number, so you can skip giving the modulus sign. Equal to t, and this is y over a equal to e to the power of t, or y is equal to a e to the power of t. This is shown. Okay. Coming to I. So that dx dt minus x equal to negative a times e to the power of t, and dx dt is this. So dx dt is equal to x minus a. Y is a times e to the power of t from I. So this is dx dt minus x is equal to minus a times e to the power of t. This is again shown. Okay. Coming to the third subpart. I solve the differential equation in part I, that is this. We have to solve this equation. To find x as a function of t and it is containing 4 marks. So, and for this we require the integrating factor, of course, and the integrating factor will be of this form e to the power of p dx, integration of p dx, where p is equal to -1. Okay. So the integrating factor is equal to e to the power of, and I have written dx because when we have the equation in the form of dy dx, but over here we are having the equation in the form of dx dt, so it will be p dt. Okay. So and p is -1, so it is negative dt, which is equal to e to the power of negative sign and then the dt, integration of dt, which is e to the power of -t. Okay. And we have to multiply every term of this differential equation by this integrating factor e to the power of -t. Therefore, e to the power of -t dx dt minus x times e to the power of -t equal to negative e to the power of positive t times e to the power of -t. And e to the power of positive t times e to the power of -t is e to the power of 0, which is 1. So this is equal to -e. Okay. So this implies this left hand side can be written as the derivative of e to the power of or x times e to the power of x negative t rather, x times e to the power of -t, and the differentiation is with respect to t. It will be a product rule. When we differentiate x, we get dx dt, and when we differentiate e to the power of -t, we get negative e to the power of -t. So the left hand side is the derivative of x times e to the power of -t. When we differentiate this with respect to t, we get that to those two uh, terms, and this is equal to -e. So if we differentiate, we integrate both sides with respect to t. It is dt. Okay. So we are integrating both sides. I have kept the minus sign outside. I could have taken the a also outside, but I don't have space. Or else I could have taken the minus sign inside also. Whatever you want, you can do. So what we are doing is nothing but we are integrating both sides with respect to t. So this is giving us the answer as x e to the power of -t from the left side integration, and from the right side we are having -e times t, and there should be one constant of integration. Okay. We are having two integrations, so there will be a constant of integration from the left side, there will be another constant of integration from the right side. I have combined those two constants of integration and I have written one constant of integration, that is c. And I have to give x, so we are having x times e to the power of -t. So what I can do is I can multiply both sides by e to the power of +t. Or you may say that you may divide the entire equation by e to the power of -t. Either you multiply the entire equation by e to the power of +t, or else you divide the entire equation by e to the power of -t. So this will be giving you x times e to the power of -t times e to the power of +t. E to the power of -t times e to the power of +t is, you know, e to the power of 0, which is 1. So we have x equal to -a times t times e to the power of positive t plus c e to the power of positive t. So this is the function of x, or x as a function of t. This is the equation giving the relation between x and t. Is a function of t. X is a function of t. So we are having the answer as x equal to negative 80 times e to the power of t plus c times e to the power of t. Okay. So we move on to the subpart B. Now consider the case where a equal to negative 1. Subpart B, it contains 4 subparts. I is by differentiating dy dt equal to negative x. Actually, dy dt was equal to ax plus y because a is negative 1. So dy dt equal to negative x plus y. With respect to t, show that d2y dt square equal to 2 times dy dt. And dx dt expression was given to be equal to x minus y. Okay, so we can start with I. So we are differentiating both sides with respect to t. So it is d2y dt square is equal to negative dx dy, dx dt plus dy dt. And dx dt equal to x minus y, therefore negative dx dt should be equal to y minus x, and or minus x plus y. And what is minus x plus y? Minus x plus y is dy dt. Okay. So this is equal to minus x plus y plus dy dt. And minus x plus y is dy dt. So dy dt plus dy dt, which is equal to 2 times dy dt. Okay. So shown. I by substituting y equals dy dt, show that this capital Y is equal to b times e to the power of 2t, where b is a constant. So okay, and fine. So we take this equation. Okay. So d2y dt square, since capital Y is equal to dy dt, so d2y dt square will be d capital Y dt. Okay. So d capital Y dt should be equal to y, or d capital Y over capital Y equal to 2 dt. If we integrate both the sides, we get ln of capital Y. I am not writing the modulus because these are positive real numbers. So if you want, you may put, but you actually do not need them to be given the modulus sign. Okay. And equal to 2t. And since there is the b given, therefore I am taking ln of b. You can take any other constant. So this is ln of y over b equal to 2t, or y over b equal to e to the power of 2t, which is giving us, capital Y equal to b e to the power of 2t. Okay. So this is what we're asked to give. We have shown this. Okay. We come to subpart I. Hence find y as a function of t. Hence find, so capital Y is dy dt. So dy dt is equal to b e to the power of 2t. Therefore, dy equal to b e to the power of 2t dt. Okay? Which is y. You could have written, I could have written integrating both sides with respect to t. So dy dt and b e to the power of 2t dt getting integrated. I have just skipped that step. If you want, you may write it. Equal to, b is a constant. So an integration of e to the power of 2t is e to the power of 2t over 2. This e to the power of 2t over 2, maybe plus c. Hence find y as a function of t. So y is as a function of t is this. Okay. So the subpart IV part 4 is hence show that x equal to negative b over 2 e to the power of 2t plus c, where c is a constant. X is over here. So let us start with okay, dy dt equal to negative x plus y, and dy dt was equal to capital Y, and we have shown capital Y to be equal to b times e to the power of 2t. Okay. So this is b times e to the power of 2t equal to minus x, and we have seen y as this. So this is b over 2 e to the power of 2t plus c. Okay. And over here they have given c as a constant. Okay, let me see. If I have to change the letter, I'll be changing. So x should be equal to, I'm adding x to both the sides, so x comes over here, and I am subtracting b e to the power of 2t from both the sides. Okay, so subtracting b e to the power of 2t will be giving us e to the power of 2t b over 2 minus b plus c. Okay, so half b minus b is negative half b. That is why you are getting minus b over 2. So therefore, this is x equal to negative b over 2 e to the power of 2t plus c. Okay, I don't have to change the letter. C is fine. So we have solved all the subparts of subpart B. Let us move on to subpart C. Okay. Now consider the case where a equal to negative 4. Okay, so dy dt equal to ax plus y. So dy dt equal to negative 4x plus y. C, subpart C, it has three further subparts. Subpart I says show that d2y dt square minus 2 dy dt minus 3y equal to 0. Okay, so let us differentiate this one. d2y dt square should be equal to, I'm writing minus 4 in place of a. So minus 4 dx dt plus dy dt. Okay, and dx dt is this. So this is minus 4x minus y plus dy dt. Okay, fine. This is dy dt. Okay, so and then and minus 4x plus y is dy dt. Why do I need this? Because I need 2 dy dt. 1 dy dt I am having, I need another one. So minus 4x plus y in place of minus 4x plus y, I can write dy dt. And this is minus 4x plus 4y. So from minus 4x plus 4y, I am taking minus 4x plus y. Okay? So this can be written as dy dt plus 4y. It was plus 4y. I have taken only a single y. So I am having 3y remaining plus dy dt. Okay? So this is d2y dt square. I am bringing all the terms to one side. This is 2 dy dt. So it is 2 dy dt minus 3y is equal to 0. Shown. From previous cases, we might conjecture that a solution to this differential equation is y equals f times e to the power of lambda t, where lambda is a real number and f is a constant. The part I says find the two values of lambda that satisfy d2y dt square minus 2 dy dt minus 3y equal to 0. That is the first equation of subpart C. Okay, fine. So we can start the subpart I answer from this point. So y is equal to f times e to the power of lambda t. So what is dy dt? dy dt is f lambda e to the power of lambda t, and d2y dt square is equal to f lambda square e to the power of lambda t. Okay, so I'll be substituting these expressions in this equation. So if lambda square e to the power of lambda t minus 2 f this one lambda e to the power of lambda t minus 3 this one f e to the power of lambda t equal to 0, and if I take f e to the power of lambda t common, I get lambda square minus 2 lambda minus 3 equal to 0. If is a constant, f is not equal to 0, because if f is 0, then y is 0. So if is not equal to 0, they have said y is a positive real number. So f is not equal to 0, e to the power of lambda t is definitely not equal to 0. Therefore, this part should be equal to 0. So lambda square, I can write this as plus lambda minus 3 lambda minus 3 equal to 0. Okay? So lambda, if I take lambda is common, so lambda plus 1 and minus 3, lambda plus 1 equal to 0. Therefore, lambda is equal to -1 or +3. Okay, because from lambda plus 1 I'll be getting lambda plus 1 equal to 0, I'll be getting the -1 value of lambda, and lambda from lambda minus 3 equal to 0, I'll be getting the +3 value of lambda. So these are the two values of lambda. Okay, sometimes it's erased, sometimes stays. Okay, but anyway, coming to subpart I. Let the two values found in subpart CI be lambda 1 and lambda 2. They are in fact -1 and 3. I says verify that y equals f times e to the power of lambda 1 t plus g times e to the power of lambda 2 t is a solution to the differential equation CI. This is the same equation where g is a constant. Okay. So I'm writing lambda 1. I have written -1 first. So lambda 1, let it be -1, and lambda 3 is, sorry, lambda 2 is 3. Okay. So y is equal to, so let me write y over here. Y is f times e to the power of -1 is negative t plus g e to the power of 3t. Okay. So now again I come to dy dt because I have to get this equation. Dy dt equal to derivative of e to the power of negative t is negative e to the power of negative t. So it is minus f e to the power of negative t and plus 3g e to the power of 3t. d2y dt square will be equal to f e to the power of negative t and plus 3 times 3 is 9, 9g e to the power of 3t. Okay. And now coming to the equation. Therefore, or let me write over here next line because it may be a long one. So f e to the power of negative t plus 9g e to the power of 3t minus 2 dy dt. dy dt is this one. So minus 2, so it is plus 2f e to the power of negative t. And minus 2 times plus 3 is -6. Minus 6g e to the power of 3t. And minus 3y. Why is this? Or why is this one? So minus 3y. So minus 3f e to the power of negative t and minus 3g e to the power of 3t. What are we having? Okay. So we see 2f e to the power of negative t and plus f e to the power of negative t is 3f e to the power of negative t, and we are having -3f e to the power of -3. So these two will be getting cancelled. Is 3. Over here we are having plus 9g e to the power of 3t, and this is minus 6g e to the power of 3t and minus 3g e to the power of 3t. So this is equal to 0. Okay. Therefore, the equation d2 d2y dt square minus 2 dy dt minus 3y equal to 0 is satisfied when I sincerely hope that you are being able to see. I'm just dictating. Is satisfied when y equals f e to the power of negative t plus g e to the power of 3t. So this is the answer. Verified. This is the answer, and we have solved the question number 2 totally. So this completes our paper 3, and from our next session, we will be starting with the 2022 papers. And I'm Nilanjana Sanyal. I am an online IB Math A, SL, and HL level tutor. I tutor students from both within India and outside India. I tutor in one-on-one basis, and I also have small group online tutoring sessions. And in case you are liking my videos, currently I am solving the past paper questions of the IB Math A HL past papers. And in case you are liking my videos, my explanations, please do give the videos a like. And please do share these videos with your friends so that even they can get benefited by watching these videos. And if you have some questions, if you have some suggestions, please do feel free to write to me in the comment section. I'll be going through them and I will be trying to modify myself or my working as much as possible. Okay? And please subscribe to my YouTube channel and don't forget to press the bell icon so that you get notified as soon as I publish a new video. Sometimes I usually publish videos on Monday, Wednesday, and Friday, but sometimes I don't get sufficient time, or maybe the time when I'm publishing on those very days are not the same. So you please press the bell icon. You will be getting notified as soon as I publish a new video. And thank you for staying with me till the end. We meet again in our next session very soon, where we'll be starting with May paper 1, May 2022 paper 1 time zone 1. Okay? So till then, bye.